We are back with another video. You're going to need a paper or your notebook, a ruler, protractor, and I'm going to try to use whatever colors I can because I received all of these markers as a gift. So, if you didn't know, we are going to do Mr. J's notes. Title. Summary. And the area for the topics. Alright, we're going to call this one polygons and regular polygons. Polygons and regular polygons. We're going to learn exactly what this word here means. So let's first look at the word polygon. And I'm going to use my colors. We have the word poly. And we have the other half of that, which is gon. So poly has two parts, poly and gon. Poly has to do with having multiple. So poly, multiple. Polymer, I'm not going to pretend I know exactly what that means, but it has to do with multiple. And gon, which essentially means angles. The word polygon means, I'm going to put it over here, multi-angular. So now we can see why shapes are called polygons. So I know what polygon means. But maybe right now we're not exactly sure what regular polygons are. So the word regular, and I'm going to write this in black, is a polygon or a shape with multiple angles that has all sides and all angles congruent. So, let's go put a quick example under here with what color I want to use. Purple. Equilateral triangles are regular polygons. So equilateral, regular polygons. The fun thing about these words is we're going to figure out exactly what lateral means in a little bit. So we have our definition of polygon, multiple angles, and regular polygon, meaning all of those angles and sides are congruent, which means the same shape and size. So let's look at some polygons. We're going to do a lot here. I don't expect you to remember all of them, but I want to divide this, but I don't know how much space I'm going to need, so I'm going to start with just doing that. So let's look at the words we have here. I'm going to put on the left side our ways to count. So we have tri, tetra, penta, hexa, octa. Let's see, 1, 2, 3, 4, 5. I'll go over here. or yeah, hepta. Octa. Nona. Deca. Hendeca. And I'm going to stop there, and you'll see why. So, and now I'm going to end it here because I know how much space I need. So, if you look at the color coding, poly means multiple, and all of these are in the same color. So these refer to the number. Tri is 3, tetra 4, penta 5, hexa 6, hepta 7, octa 8, nona 9, deca 10, hendeca 11, dodeca 12. In dodeca, do comes from 2, and then deca, as we see here, is 10. So dodeca is kind of like 2 plus 10. It's all Latin, which is really cool. Now, for almost all of them, we can add gon. Tetragon. Is that right? Yeah. Tetragon, pentagon, hexagon, heptagon, octagon, nonagon, decagon, hendecagon, and dodecagon. And the only one that doesn't truly follow this pattern is triangle. But we know gon means angle, so triangle. It could just be trigon. So triangle has 3 angles, 4 angles, 5 angles, 6 angles, 7 angles, 8 angles, 9 angles, 10 angles, 11 angles, and 12 angles. I'm sure there's words for 13, 14, 15, and whatever people wanted to do until they got bored. Alright, and I'm going to put a note here. I want to talk about tetragon. Now, the word tetragon exists, but it's not the most common. The most common one, I would say, is quadrilateral. So maybe you've heard the term quadrilateral. That's what we would call something with 4 angles, but really, quad is another way of saying 4. 4. And instead of talking about the angles, lateral talks about the sides. So quadrilateral means 4 sides. And now, let's look at the word equilateral. Based on your understanding, if quadrilateral means 4 sides, what would equilateral mean? If we think about an equilateral triangle, that means equal sides. So equilateral triangle is a triangle with equal sides. Now, as we talked about, really, we don't want to use the word equal, we want to use congruent. But equilateral gets the point across. You could say congruent or equal measure. So it's sides of equal measure, not equal sides. Good, so let's review. Polygon, poly multiple, gon angles, multi-angular. Regular polygon are polygons that have all sides and all angles congruent. Equilateral triangles are regular polygons because all the sides and angles are congruent. And we have all the polygons here. Tri, tetra, penta, hexa, hepta, octa, nona, deca, hendeca, dodeca. Oof. And that refers to the number of angles. It's not creatively named, but if you can memorize it, it's convenient. And the last one we want to look at was tetragon, but we really call it quadrilateral, meaning 4 sides. So instead of 4 angles, which is a tetragon, quadrilateral is 4 sides and equilateral. And now, this is usually your summary, but I'm going to do it for you. Because I wanted to talk about one more thing that we don't have room for. We're going to look at 2 things. Polygon and regular polygon. Let's look at 4 sides, 5 sides, and 6 sides, or angles. Regular polygon for 4 could be this. Oh, sorry, you can't see that. It could be this. It could be no, it's not going to connect. I don't know, I messed up. Okay. I don't have whiteout, so we're going to just do this. It's 4 sides. But a regular polygon, if they're all the same, that can only be, and we call this a special name, square. 5 sides, I'm just going to do 1 here. The one that everyone does. Now, this house is technically a pentagon because there's 5 angles, but when we talk about a regular pentagon, this is not going to be perfect, but it looks something more like this. Okay, so this would be a pentagon, regular pentagon. 6 sides, you could do something like this if you wanted. Again, it's not perfect, but a regular polygon would be perfect. So quick review, this is not neat with those, but I don't want to do liquid paper. Polygon just refers to the number of angles. Regular polygon refers to the number of angles that are equal. So all of these angles ideally would be equal. Thank you.